So we're going to talk about exponential functions and whether or not they have asymptotes. And so to do this, we're just going to kind of take a look at what happens to this exponential function, 2 to the x, as x increases. So let's start off with 0. What happens when x is 0? Well, 2 to the 0th power is just 1. So that's pretty simple. And what's going to happen, let's say, when x is 2? Well, 2 to the 2nd power is 4. I'm going to be up here. What's going to happen if we skip really far down the road and get to 10 or something? Well, 2 to the 10th power, you could compute that. It's a very, very big number. So it's going to be way up there. So as I move to the right, this exponential function is just going to keep getting bigger and bigger and bigger. And so towards the right, there's really no asymptote. It doesn't seem as though there's anything that it's tending towards. It just gets steeper and steeper and steeper as I move towards the right. But what will happen as I move towards the left? And so we want to consider is what would happen if the exponent were negative 2? And this is a good question. What is the value of 2 to the negative 2? And if you type this into Wolfram Alpha or something like that, you're going to end up getting 1/4. 1/4. What's 1/4? Well, 1/4 is 1 over 2 to the 2nd power. And in fact, that's how negative exponents are defined. So I'm going to quickly just kind of talk you through this. So take some number 2 and raise it to a negative number. Okay? So if I raise it to a negative number, let's call it negative n, that is the same thing as taking 1 divided by 2 to the positive n. And you might wonder, well, why is that the case? Why would it be that if I'm raising something to a negative number, it all of a sudden is equivalent to 1 over 2 to the positive version of that number? And so here's how we'll talk about it. So remember that if you have, let's say, 2 to the negative 2, and you multiply it by 2 to the positive 2, what will you get? Well, we all know how to simplify this. If the bases are the same, we add the exponents. So we should get 2 to the 0th power, which is 1, right? No big issue there. So let's think about what that means. Well, we know that 2 to the 2nd power is 4, so the only question mark is what is 2 to the negative 2? In other words, what will I multiply by 4 to get 1? And hopefully you guessed, what do I multiply by 4 to get 1? Well, I multiply it by the reciprocal, or 1/4. So 2 to the negative 2 has got to be 1/4. In other words, 1 over 2 to the positive 2. And so that's where we get this definition of if you have a negative exponent, it's 1 over 2 to the positive version of that exponent. Okay? So 2 to the negative 2 is 1/4, so it'll be down here. And what will happen as we get to 2 to the negative 10th? Well, you can compute that. You could type that in to Wolfram Alpha or something like that. 2 to the negative 10th is going to be 1 divided by 2 to the 10th. And that's an incredibly small number because 2 to the 10th is a big number, and 1 divided by a big number is very, very small. So it's even smaller. It's way, way smaller. So if we're connecting these, we should see that we're getting closer and closer to what? We're getting closer and closer to 0. And that's, in fact, the asymptote of this function, 2 to the x. And it would be the asymptote of any exponential function. So 100 to the x also has the same asymptote of y equals 0. It has a horizontal asymptote at y equals 0. So the key takeaway here is that as I move towards the left, as x gets further and further negative, moves further and further to the left, the exponential function will get closer and closer to 0. That's a good thing to write down and commit to memory. And then you can use this to find the asymptotes of other functions. So for example, if I had the function 2x plus 2, this might have a slightly different asymptote, and you could actually figure that out by thinking about what will happen as x gets further and further negative. Okay, so that's a good exercise to do, and you'll actually think about that in the homework.